Okay, in this mini lesson, we're going to talk about how to simplify rational expressions. And to do this, we are going to remember what we did in elementary school in simplifying fractions, and you may have called it reducing them to lowest terms or something along those lines. But that is going to be the basis of how we simplify expressions that are rational and have expressions and variables in them. So let's go ahead and start with the first example here. We have a pretty simple fraction of 16 divided by 56, and we want to simplify that completely. And so most of you would say, oh, well, there's a common factor of 8 in there, and that's absolutely right. Well, that's 8 times 2 in the numerator, right? And 8 times 7 in the denominator. And that's absolutely true. So really what we're doing in this process is we're taking this fraction with products in the numerator and the denominator, and we are going to break those apart because this is the same as 8 divided by 8 times 2 divided by 7. And so that's the reason why we can take out this factor of 8, is because this 8 over 8 really turns into 1 times 2 over 7. So our net result is just going to be 2 over 7. So our whole process hinges around finding common factors that we can divide out. That's important. Okay, let's try another one. This time we're moving to another fraction, but it is with variables instead. But you probably see that the variables include something in common, right? A common factor. So we've got P times Q over P times R. Now, if we think of that as P divided by P times Q divided by R, well, of course, that P over P is equivalent to 1 times Q over R. And so that 1 is not necessary anymore. The common factors divide out, and we're just left with Q over R. All right, in this next example, the factors are not clear. They've been multiplied out, and we need to break them apart and see what those factors are. If you look at this example, you can probably tell that the numerator has a common factor that we can divide out. And we can say, well, that's going to be 7 times x minus 2. And in the denominator, we can say, oh, there's a common factor of x, so we can divide that out, x times x minus 2. Beautiful. Now, when we write it in terms of factors this way, we see that there is a common factor. That x minus 2 times x minus 2 is equivalent to 1. Okay, and we can divide that out. We can say that this simplifies to just 7 over x. Now, this last example has a little more factoring involved. It's the same process, but there's more factoring. Notice on the numerator here we have a difference of cubes. So we're going to factor that out as we would a difference of cubes with a binomial and a trinomial. The binomial is just the result of taking the cube root of both terms and keeping the sign. The trinomial is built from that binomial, so that's going to be x squared plus 3x plus 9. If you don't remember how to factor a difference of cubes or sum of cubes, you can go back to that video and remember that. And then if we look here in the denominator, we can see right away in these three terms, they all have a common factor of 2x. So let's start by factoring that out. Okay, so we've got, if I factor out a 2x from 2x cubed, I've got x squared. If I divide it out of negative 4x squared, I've got negative 2x. And if I divide it from negative 6x, I've got minus 3. Okay, looking good so far. Now I notice that what I have as a result here is a quadratic expression, which actually looks like it probably factors further. So let's recopy the numerator. So we've got x minus 3 times x squared plus 3x plus 9. And then the denominator, that 2x is going to just come along for the ride. And then what does that quadratic factor into? Factors of -3 that add to make a -2. I think that's going to be x minus 3 and x plus 1. Okay, now this is fully factored, and we see that in the numerator and the denominator, there is a common factor of x minus 3. So we can actually divide that out because x minus 3 divided by x minus 3 is 1. And whatever's left and does not divide out becomes our simplified rational expression. So we have x squared plus 3x plus 9 divided by 2x times x plus 1. And you can leave it that way, or you can distribute that 2x through in the denominator. It's kind of nice to leave it in factored form because then you can see if anything else needs to divide out. Okay, we're going to use the simplification process when we move on into multiplying rational expressions, and that's up next. See you later.